Dear students, as a continuation of the previous topic on irrotational under vector differentiation, here we have problem 58. So kindly follow the previous video lectures on the topic curl and irrotational vector to understand this better. Now here we have the problem which says that if a vector is equal to axyi vector plus x square plus 2yzj vector plus y square k vector is irrotational. Find the value of A. So if you see A vector is given here, it is also given that A vector is irrotational. So it is given that A vector is irrotational, which means nebula cross A vector is equal to 0 vector. So this is given for us. And there is an unknown over here. So we have to find this unknown A. So now in order to find that, we are going to use this concept. So what is nebula cross A? We know that nebula cross A vector is given by the determinant value of I vector, j vector and k vector, then dou by dou x, dou by dou y and dou by dou z. And here we have the ith component, which is a x y, and here jth component, which is x square plus 2yz, and here kth component, which is y square. So now it is given that this determinant value is equal to 0 vector. So now we shall find the determinant value. So the determinant of this matrix is, first we have I vector here. So I vector multiplied with, so block this column, block this row. So we have to find the determinant of this matrix. So this into this, that is dou by dou y of y square minus this into this, which is dou by dou z of x square plus 2yz. And then we have j vector, for which we should write minus j vector multiplied with, block this column, block this row. So dou by dou x of y square. So dou by dou x of y square minus dou by dou z of axy. So dou by dou z of axy. And then we have finally k vector. So plus k vector multiplied with, block this column, block this row. So this into this minus this into this. So it will be dou by dou x of x square plus 2yz minus dou by dou y of, so this into this, so axy. And all this is equal to 0 vector, because we know that the determinant of this value is equal to 0 vector since a vector is irrotational. So this will be equal to 0 vector. And so from this, I vector multiplied with, what is the partial differentiation of this with respect to y? It is 2y minus the partial differentiation of this with respect to z. This will be 0, and so you will have 2y over here. And then minus j vector multiplied with, here partial differentiation of this with respect to x, we do not have an x term, so it will be 0. And partial differentiation of this with respect to z, we do not have a z term, so this is also 0. And then plus k vector multiplied with, here we have the partial differentiation of this with respect to x, so it will be 2x, so 2x. And then this will become 0 minus, and here partial differentiation of this with respect to y. So when we differentiate y, it will be equal to 1. So 1 multiplied with ax, because a and x will be constants, so it will be ax. And all this is equal to 0 vector. Now since this is 0 vector, so from this we have 0 I vector minus 0 j vector plus here we have 2x minus ax k vector is equal to 0 vector. So we know that each of the components are equal to 0 since the right hand side is a 0 vector. So definitely this also will be equal to 0. Therefore we will be having 2x minus ax to be equal to 0. We can take x common here. So 2 minus a multiplied with x is equal to 0. So from this we can write 2 minus a is equal to 0 and the value of a is equal to 2. So therefore we have evaluated the unknown a given in the problem, which is equal to 2. Here we have another question on the same topic. Find the value of a, b, c. Now here we have three unknowns. So a, b, c, if f vector which is given by this, so this is k vector, f vector which is given by this is irrotational. So it is given that f vector is irrotational. So that implies that nebula cross f vector will be equal to 0. The curl is equal to 0. Now using this, we have to find the values of a, b and c. So the unknowns a, b and c are given here. So let us do that. For that, first we have to find nebula cross f vector. We know that nebula cross f vector is given by the determinant value of, first we have I vector. So let me write this also. Then we have dou by dou x. And what is the ith component? X plus 2y plus az. Then we have jth vector, dou by dou y, and what is the jth component? Bx minus 3y minus z. And then we have k vector, dou by dou z, and what is the kth component? This one, which is 4x plus cy plus 2z. So we have to find the determinant of this value. So the determinant will be equal to, so nebula cross f vector is equal to the determinant of this, which will be, first we have I vector multiplied with this into this minus this into this. So dou by dou y of 4x plus cy plus 2z minus dou by dou z of bx minus 3y minus z. So this is for ith component. Then we have minus j. So minus j multiplied with, so block this column and this row. So it will be dou by dou x of this term. So dou by dou x of 4x plus cy plus 2z minus dou by dou z of this term. So dou by dou z of x plus 2y plus az. And then finally we have the kth component. So plus k vector multiplied with, we have to block this column, block this row. So it will be this into this minus this into this. So dou by dou x of bx minus 3y minus z minus dou by dou y of, so this into this, so x plus 2y plus az. So all this is equal to what? It's equal to 0 vector. So let us simplify this further. So on simplification, first we have I vector multiplied with, so what is the partial differentiation of this with respect to y? This will become 0, this will become 0. So here alone we have y, so it is c into 1, so c minus partial differentiation of this with respect to z. This will become 0, this will become 0. Only this will be there, so minus 1. So c minus 1, and already we have a minus here. So minus into minus will become plus. So c plus 1 minus j vector multiplied with partial differentiation of this with respect to x. So this will be 0, 0. So for x it is 1. So 1 into 4. So it will be 4 minus, and here we have partial differentiation with respect to z. So 0, 0. So this will be a. So 4 minus a plus k vector multiplied with partial differentiation of this with respect to x. So this will be 0, 0. So for this alone we have to differentiate b into 1. So it is b minus, okay, then partial differentiation of this with respect to y. So this and this will be 0, and we will have only 2y. For 2y, for y it is 1, so 2 into 1, so we will be having b minus 2, and all this is equal to 0 vector. Now since the right hand side is a 0 vector, each of the component will be equal to 0. The reason behind is, we know that 0 vector is 0i vector plus 0j vector plus 0k vector. Therefore, comparing the components on both the sides, we will be having c plus 1 to be equal to 0. So from this, we will get the value of c to be equal to minus 1. And from this, we should take this negative sign also. So negative 4 minus a will be equal to 0. So if anyway 4 minus a will be equal to 0, from which we get the value of a to be equal to 4. And then we have b minus 2. So b minus 2 is equal to 0. From this we get the value of b to be equal to 2. So therefore we have obtained the value of a as 4, b as 2 and c to be equal to minus 1. So I hope by now you must be very clear with the concept of finding the unknowns, using that the given vector is irrotational. So we will further learn about the scalar potential in our next video lecture. So kindly follow the next lecture to understand the topic scalar potential. Thank you.